All right. Welcome, everyone. Been a tough week, I guess. How are you feeling? Good? Enjoy TechEd? Great. So today, myself, Milad, and Jeff Stokes, part of Global Business Support, we want to talk about Windows performance and how you can troubleshoot slow boot as well as high resource consumption. And, you know, who didn't see enough PowerPoint so far? I thought so. So I want to start straight away with a demo and do a kind of reverse engineering. So I will do a demo, then explain some insights, and then finish up with a demo again. Does that sound good for you? Yeah. Awesome. Cool. So let's see if that worked. Perfect. So that's my Surface Pro. Well, it's not mine one, actually. I tried to get one, and maybe you know Microsoft employees don't get a Surface Pro here. So I just borrowed from a colleague his one. All right. So how do you troubleshoot Windows performance? At the moment, we have the Windows Assessment and Deployment Toolkit. It is so the ADK, which you can get from Microsoft.com. This one contains the Windows Performance Toolkit. And I just want to walk you through quickly where you get it and how do you install it. And after on, I will show you some really cool demos about that. So let me just go to my favorite search engine. Type in Windows ADK. And there, I can straight away download the current ADK, so Windows Assessment and Deployment Toolkit for Windows 8. So it says for Windows 8, but the Windows Performance Toolkit works as well and is supported for Windows 7 at the same time. So I would download it. And we didn't experience some network issues today, right? So I prepared it. OK, so when you start the ADK setup, you will have two options. Either you can install it straight away on your machine, or you can download it so that you can copy it, to, for example, to another machine, and then go ahead to install it over there. So you get an offline version of it. So since I was mentioning some network issues, I tried this morning. I woke up at 6 a.m., came over, starting downloading, and it was, at the moment, it's at 75% at my host machine. So I prepared another one, another executable already. So imagine I click now here. It will ask me if I want to join the customer experience program whatsoever. I say no. I say yes, of course. Hang on. Yes, I want. Yeah, I read carefully the license agreement, as always. Like everyone reading license agreements, right? Of course.
Light reading.
Yeah, all we do, right? You know, I like actually some websites, they say, oh, you need to scroll down, and then you need to accept.
Yeah.
I wonder how, if they are tracking the time, actually, how long it takes to scroll down. I'm pretty sure it's like 1 second.
Sure.
All right, click on Accept. So now I'm able to choose which feature from the Windows ADK I want to install on my computer. So I have the option to go with the Application Compatibility Toolkit and many more deployment-related tools. Where I want to focus on is the Windows Performance Toolkit. So I unclick those. Oh, yeah. And would hit Enter. Yes. And now it would basically start downloading from Microsoft servers the Windows Performance Toolkit in version 5 and install it on my machine. So since this will take for ages, I have the redistributable also ready, which is this one. So please just believe me, that is the official way. You know. So now it is installing the Windows Performance Toolkit. Done already, super fast. And now if you go to the modern UI, you will have two new apps, which are legacy applications, so they're not modern apps, but will appear in the start screen. So the first one is the Windows Performance Analyzer, which is the user interface in order to analyze the traces, and the Windows Performance Recorder, which is, well, it is responsible to record the performance issues. So let me start the Windows Performance Recorder. So that's how it looked like in a basic version, let's say. If I click, let's click on more options. So within the Windows Performance Recorder, I have now the option to say, okay, I want to trace a general trace, so which means it's a post-boot trace. So let's say you have high CPU, high disk I/O issues, so you would go for a general trace. Or you can say, you know what, I want to trace a boot scenario. I want to trace fast startup for Windows 8, reboot cycles, and so on. You can do that all with the Windows Performance Recorder. You can choose which detail level you want to actually really record. So do you want to have all the last bits, so the threads, what they are doing in nanoseconds or not? And lastly, do you want to log it to the memory or to file? Additionally, what's also great is we have now scenarios. So you can, for instance, say, I want to have a general trace, but I want to focus in this trace particular on CPU usage. So you will get even additional providers, ETW, event tracing for Windows providers, activated. And here we have the scenarios. So you can say, I want to have a Windows Performance Recorder to trace Internet Explorer. Who didn't have any issues with Internet Explorer performance? Oh, I shouldn't say that, right? Probably right. But it's better, right? Like Internet Explorer 10 compared to 8, 7?
Yeah.
Yeah. Okay, as well as audio glitches, video glitches, you can trace that all with this tool. So what I really like about this tool, in version 4, so the previous version, all of that you need to know in your brain because there was a command line. So you need to know the syntax. Now you have this friendly user interface, and I think it helped our life, really.
Yeah.
So both of us are mainly dealing with Windows performance issues at our most strategic enterprise customers, and it was really painful sometimes to find the right syntax in order to gather the right logs so that we can troubleshoot that. All right, so let me take an example trace. So now it's activating the appropriate event tracing for Windows providers. It is logging already. So since it's just a test, so you can see the UI, I will stop it here. I can enter a description. Oh. TechEd rocks. Oh, no.
Close.
Close, right? Rocks, smiley. Hit on save. And now let me just go into the folder where I have it stored. So it's in C, users, demo, my documents, WPR files, Windows Performance Recorder files. And now if I start that one, it will start the Windows Performance Analyzer. And just to let you know, really listen carefully, I have some really cool giveaways. So I will have to ask some questions, and whoever is the first one who finds out the correct answer will get something nice from me. Like stuff like that. I tried to get a surface, but product group, BG, said no, no chance. If you want to pay from your own pocket, you can do it. All right. So this is the new user interface for the Windows Performance Analyzer. You don't see much, right? So the beauty about the new version is that you can choose what you want to see, and you don't get too many information at the same time. So on the left side, you have the Graph Explorer. And now basically you can choose, OK, so I want to have information about, let's say, Windows in focus. So which window was in focus when I was tracing this file, when I was tracing the computer? Or I want to focus on threads. What are the threads doing at that time? And so on. So depending on your need, you can really now choose what do you want to see in the Windows Performance Analyzer. So here, for example, now I'm in the CPU usage, and I can see straight away, OK, which application or which executable is causing the most CPU consumption. Great, huh? All right. So let's move over to a real case, let's say. So this is just an introduction, so you get familiar with the Windows Performance Recorder and Windows Performance Analyzer. What are the two components I was talking about? Recorder and? So let me just, oh man.
Heads up.
Okay, I give it another try. Come on.
Careful. You're going to bean somebody, man.
Terms and conditions apply, you know. Microsoft not responsible for any harms and blah, blah, blah.
Everyone signed the EULA before they came in here, right?
Yeah. Yeah. Sorry. All right. So this is my Hyper-V environment, my small Hyper-V environment. I got my server over here. And what I will do now is I want to show you how you can troubleshoot high disk I/O. So for this, I'm starting now my client machine. I don't need the server.
While he's doing this, one of the things that you can kind of take away from this is that in addition to being able to troubleshoot why the disk light's blinking on that machine when it boots and sits there and grinds and grinds and grinds, you can also use this in a SAN type environment or any other server type environment to understand where the disk utilization is there as well. It's not enough to know that we have high disk latency and disk is being used. We need to know why, and this tool can be used for that.
Exactly. So really the tool is that powerful, you can break the system in nanoseconds. Nanoseconds. I believe if the CPU could offer like something better, the tool could do it. But the CPU limitation says nanoseconds. So, I mean, can you imagine nanoseconds? You can really see in the tool, the threads, what they're doing on nanosecond level. All right. Actually, it was the other machine, just realized. Should be fast. Running on an SSD.
Good.
There you go. Okay. Let's type in my super secret password, password 1. Oops. Anyone attended any Microsoft training so far before?
Yeah.
Standard password, password 1.
Right? Yeah. Mostly.
Mostly. Or we also have Corp $123.
Oh, that's a European thing. I don't know.
Yeah, so I'm based out of Germany, and our standard password is Corp $123. If you ever attend a conference in Europe, you will see that password. All right, so this is my Windows 8 demo machine. Let me go over to full screen. This is resolution. All right. So what I want to do is now, I show you first of all the current performance of this machine. So you can see disk activity is at around 5%, right? Okay, so now, I'm going to open the command prompt and let me do gp update -4 to get the latest group policy configurations. Anyone notice something already? Getting up, huh? 98%. What is it? NTOS kernel version 2? Version 2 of a kernel? Interesting. Shall we dive into it and see what it's doing? All right. So let me cancel that one first. Open the Windows Performance Recorder. Yes, I want an admin token. Okay, so I don't need additional CPU information. So I just take a general trace in verbose and dump it to memory. Click Start. Let me do GP update again.
I think one of the interesting things with this tool is that you don't have to check any of the boxes to get reliable, detailed information.
Yes.
Those are just for deep dives into scenarios. So
absolutely.
Yeah.
All right, so issue appears again, right? We have NTOS kernel version 2 at 99% disk I/O. So I reproduce the issue, saving the trace, saying high disk I/O. Okay, let me copy that one. Save. So now it generated the trace for me. Let me open that file now.
Do you want to kill the process?
Oh
That's
yeah,
on your disk too?
would be faster, no?
It would be faster. There you go.
Kill it. Anyone know what NTOS kernel 32.exe is?
Yeah.
It's the kernel, exactly.
So who doesn't want version 2 of the kernel loaded on their machine, right?
Matthew, can you help the guy, gentleman, maybe? All right. But version 2, at the same time version 1 is running. Let's find out what's going on. All right, so now how we will troubleshoot this issue. So we know I'm on site. Imagine I'm on site now at the customer. Say I have high disk I/O consumption. I do exactly the same steps for the recording of the issue. And now I have the trace open. And what I will do now is, since I know it is disk related. Oh. Hang on.
Yep.
Sorry. Okay. Oh, damn it. Better?
Yeah.
All right, so since I know it is disk related, let's see what graph I have available. So system activity, yeah, sounds nice. So I might look into that later. Computation, so CPU-related stuff. No, I'm not really interested because I know already it is not CPU-related. CPU is really at a, like it was at, I believe it's 6-7%. What is interesting for me is storage. So I'm opening it and moving over the disk usage graph to the main analysis area. And now I would just highlight the area as well to see what's really going on. So I get information about the I/O time, the size, the disk service time. And something really cool here is this tiny little button over here. When I click that one, I get even additional information. Let me adjust the columns a little bit. So here now I can see like what's the priority of the disk activity. So here we have low priority, which is causing 485,000 million?
485 seconds?
408.
I/O time in microseconds, yeah, I think so.
In microseconds. If we dive into, we can see, okay, is it mainly write activity, read activity, and we see the process causing this issue. Mm-hmm. Let me just put it over here. So we can see actually that NTOS kernel version 2.exe with the process ID 2228 is causing a lot of disk I/O, not only read, but as well as write. But you know that's not enough. So I want to find out more information. So what I would do now is I basically take the process graph, open that table as well, because I want to know which command line has been really used in order to execute this process. So you know that in whatever program you're using, it's in the background, like basically executing something as a command line, right? So if you start IE Internet Explorer, it will if you open it with Process Explorer from SysInternals, you will see actually that the command line used is C system root program files Internet Explorer IEExplorer.exe, right? So and sometimes you would have additional syntax like dash whatever, and you would see those in the command line column within Xperf or Windows Performance Toolkit. So now again, I open the summary table, and having basically a look about each process. So let's see what's happening. So here I have the GP update, and here I got basically what I'm looking for: NTOS kernel version 2, which had a duration of 31 seconds. And let's see what it is doing. So here I can see the command line. Basically, it is accessing the domain controller, a share on the domain controller, and, well, I renamed this executable. It is one of our Windows internals executables to cause high disk I/O. So what it is doing is generating a huge file in the background to cause a big disk I/O issue. But this is one of the approach you would go through if you have a high disk I/O issue. Just create a Windows Performance Recorder trace, open it in the Windows Performance Analyzer, move the storage graph to the analysis area, and then you can really quickly see, okay, which process is causing this issue. In this example, it's NTOS kernel version 2.exe. And I can also see over the process graph which command line has been used in order to execute that. All right. And this is really one of the big difference between Windows Performance Toolkit and, well, let's say Task Manager. In Task Manager, you won't find that detailed informations. You will see disk I/O, executable name, but you cannot really dig into it. All right. So that's just to give you a quick idea about how Windows Performance Toolkit works in general. Clicker. So the poor CPU, poor disk is melting away. Need to talk with my boss to get a new one. He won't be that happy. I just got 4 new. OK, so now let's talk about some Windows internals, some basics. So who don't know the Windows internals book? Good.
Pretty popular.
Probably that's why those guys are here and not at Mark Rusanowicz's session. All right, so it's pretty big, right? It's, I think, 600 pages. 2 binds now. Wow.
Two volumes, yeah, 2 books.
Oh, my God.
Yeah.
All right. So actually, like, a funny thing, when I got hired at Microsoft, my boss asked me if I have the Windows internals book. And I said, yes, of course, I have the Windows internals book. And he asked, how many copies do I have of this book? I said, just 1. It's not enough. You need 2. 1 in the bathroom, 1 next to your bed. So my first weeks at Microsoft, I spent through reading this book over and over and over again. I think I read it like 6 times, but it's a tough book. So I just want to cover here a small portion of it so that you're familiar what you're seeing really in Xperf. So what is a thread? What is a process? How does a thread get actually CPU time? And to begin with, I would like to talk about the difference between the user and kernel mode. So think about it this way. Within the user mode, we not only have the application you will start, so Outlook, Word, etc., but also we will have the system processes, Windows services. So the services you would go, all of you, I'm really sure you're all IT pros, you went to services.msc already and tried to tweak a little bit there, and then, oops, realized I have to reinstall the machine. So those ones are running also there, and as well as the environmental subsystems. Within the kernel mode, we have the Windows Executive, the Windows Graphic Interface, well, as the name says, kernel, so the Windows kernel is there as well, hardware abstraction layer, as well as the also the system drivers. Anyone know actually what the real name of the kernel mode is? So we all say kernel mode, but there's another name for it, the official name. Come again? Yes, which is the privileged mode. So if you're looking into CPU white papers, they will always talk about privileged mode. But for some reason, I don't know why. Do you know why why most of the OEMs and partners talk about it as kernel mode?
It's easier.
It's easier.
Yeah. V's are hard to say in English. That's my excuse.
All right. So, and basically, the ntdll.dll is kind of the library you have for nt-kernel functions, just like, as an example, nt-create file, responsible to create a file and to process this on disk I/O. So it's really the channel between the user mode and the kernel. If you think about it this way, you have your application, which executes the kernel32.dll, which is kind of the user mode version of ntdll. So it's processed from the kernel, from the kernel32.dll to ntdll. And then the NTDLL is responsible actually to execute those commands on the Windows kernel. All right, so now let's talk about boot phases. So we start with phase 0 start, and then we invoke some more interesting stuff around Windows. I can't read that one. Well, guys, don't panic. You don't need to know that much in detail about Windows boot, but I'm sure Jeff will be able to explain it in a little bit, well, more convenient way.
Sure. So let's look at the boot process. Of course, the very beginning of a system, we have the BIOS initialization, which with UEFI, I don't know if anyone's been playing with UEFI 2.7. What is it, 1 or 3? I forget. 3, thank you. The boot process is getting quite quick. Quick enough that sometimes when you tell it to reboot, you come back and you're not sure if it actually happened or if you're still waiting for it to shut down, right? So we have the BIOS initialize. At that point, the OS loader comes up and fires up, and then we come into OS initialization. When we get into OS initialization, we start up the kernel, and it's important to note here the ready boot is essentially working at this point. And what that is basically the optimizer that's going to pull all these files up into memory in a quick manner, in a sequential manner, a more organized manner from the disk. With so we go through kernel mode, we initialize a session, session 0, when logon starts, so we can actually have users do things, the computer can talk to the domain and so forth. Explorer will fire up, so we have a user interface for the user to interact with. And then we have all of our post-boot activity, which sometimes when we go out and do an engagement for Windows desktop performance, the complaint sometimes is it boots slow, sometimes it logs on slow, and then sometimes it's, well, it came up really quick, but, you know, I can't launch anything for like 10 minutes, right?
Yeah, the mouse is really slow.
Yeah, choppy. You know, you double-click an icon and you don't know if it works, so you double-click it again and again and again, and then you have like 9 versions of the program open, right? So we go in and look at each one of these phases individually through the toolkit and analyze those and, you know, sort of figure out root cause. You know, BIOS is pretty self-explanatory. Won't spend a whole lot of time on it. You know, the BIOS is going to fire up. With UEFI, it's going to be pretty quick typically. You know, post, etc. Oh, by the way, pay attention. Let's go back one. If anyone's thinking about coming to Microsoft, these are my interview questions. Partly.
So Jeff is the guy who's, I think, doing for Western region or which region?
East region.
East region, the technical interviews.
Some, but yeah. I think it's interesting, you know, when you talk to people, how does Windows boot? How does it, you know, you talk about simple things, but do you really know what's happening when that little spinning donut's at you or the colors are flickering? It's a kind of an indicator of, you know, technical depth, but anyway, I digress. So the Win loader is going to start and load the essential system drivers. Now, I actually had a system that hung. I had a system that actually hung before kernel initialized once. So what happened is the OS loader came up and tried to figure out what hard drives it had. And it grinds on CPU for about 30 or 40 seconds at 100% on one of its cores. And the whole time that's happening, we're displaying our little colorful logo, you know, and people are like, oh, well, you know, Microsoft Windows doesn't start up fast enough. So it turns out that through ETW trace analysis, we're able to find out that the core was busy doing deferred procedure calls, trying to find out if it had a hard drive or not on a SCSI chain. Fair enough.
One of the things you want to watch out is also the boot start drivers, that they're up to date. So typically when I'm on site, that's one of the first things I check, are really the drivers they have in place. Well, first of all, supported. You would be surprised how often I'm on site. And the first thing I see is, wait a minute, like, you have this driver in that version, but it's not supported on Windows 7.
Yeah.
Why do you have it in place? Well, I got it forwarded from a colleague, and he was saying that this works, and there's a workaround. We fixed some registry things that it works, but the OEM has a updated version. Oh, we didn't know.
Yeah, yeah, it's interesting what you can run into for sure. Yeah, one of the other things is when we go back and think about BIOS also, I've run into systems that, particularly when Windows 7 first came out, people were rolling out Windows 7 images. I mean, I'm sure you guys have enterprise environments here. How many of you guys have a BIOS management policy that updates the BIOS when a new OEM comes, an OEM comes out with a new version, right? Not many.
There's one.
That's hard.
Two.
Couple.
Three.
Yeah.
Couple.
A couple. Depending on the OEM, it can be easier or harder, right? But that's something that tends to get thrown in the IT closet, right? And they were running a version of BIOS for 19,000 laptops that didn't actually support Windows 7, and it was booting really slow. And sure enough, you apply a firmware update, we cut it down 60, 70% just with a free firmware update. Now, the pity is that they had to pay for someone to come on site to say, well, why don't we upgrade the firmware, right? I mean, I'm happy to help, but yeah, whatever. All right, so the OS loads up. There we go. Now Windows kernel starts up. We start building up our data structures for Windows itself. Plug-and-play manager starts looking at all the drivers, starts enumerating things. We can see this take a bit of time sometimes. Not terribly interesting, but things are coming up here, and from Windows internal's perspective, lots happening. There we go. So now what's happening is in the session initialization, we're actually moving a lot of the work over to Windows so that the session could be initialized and we can start starting all of our services, load up the registry, start up the subsystem.
What are the typical issues we see in session initialization, Jeff?
In session initialization?
Talking about services.
Services, auto start, right? So there's the auto start group of services where if you have a service with a delay, that can cause a long logon, where that service is mandatory. It needs to start before anything else is actually allowed to happen on the box.
Yeah. So it's really important to understand their services are not just started in some random order. We use service grouping, so we have groups for each particular service. And what we often see is that particular AV vendors, they try to start as soon as possible, which is good, right? In general, I would agree. But the problem with that is sometimes that those services, which they start really early, have a dependency on network. And due to their different configuration, their service actually runs into a timeout because they have a dependency on the network service. So it runs in a timeout, network starts, network services starting, NTSVC, and then it goes back to the AV service. So that's one of the typical issues we see quite a few times when we are looking at services and why it caused a delay.
Yeah, that's it's an interesting conundrum where you want the machine to be protected before it's on the wire, but it needs to be on the wire for the service to start. Yeah. So
which won't be any big problem anymore with Windows 8 with early launch anti-malware.
Right. That's true. Is everyone aware? Oh, yeah, we won't get into that too much, but
Chris covered that.
Oh, did he? Good.
Yeah.
Good. All right. When logon initialization is basically where we're able to actually log on to the box. Service managers get to fire up things, and this is where group policy starts. Group policy can be an interesting beast in a large enterprise. We had one customer, I think they had 12 or 13,000 group policy objects in Sysvol. And they were applying a couple thousand of them to machines when they logged on.
What was the longest time you ever saw for group policy processing?
I don't know. It's been a bit, but jeez. Well, my worst crit set was 19 and a half minutes to a usable desktop.
Come again?
And that was group policy.
Long?
Yeah, 19 and a half minutes.
19 and a half. Okay, so my record is like for GPU processing on site 20 minutes for computer group policy processing time.
Yeah.
But I've seen also. Like I'm talking about so I saw this one. Actually, I saw good ones as well. So once I was on site at a customer, he wanted boot remediation, and his enterprise image, seriously, his enterprise image was booting in 1 minute. I was on site because he wanted to get it faster. 1 minute, all group policy, BitLock, everything.
I'm a gearhead. Everything can always be faster.
Yes. We found,
can't help it.
I think we remediated like...
What, 5 seconds?
No, 6 seconds.
Oh, yeah, well, there you go. Yeah, that's awesome. And then basically we get into, the Explore initialization. We start painting desktop. We, get the Windows Manager running, start some Windows services related to user mode. Memory Manager starts loading profile, things like that. And then we get into the fun post-boot activity, scheduled tasks, logon scripts. I had a company that they had a logon script that painted a VB window that said the logon script is done running, and at the same time it did, it invoked another logon script. Well, yeah, you're not lying. That logon script is actually done, but we can see here that you spawned like 1 or 2 more, and they ran for like 7.5 minutes trying to delete a directory they didn't have rights to. I mean, help me out here. You can see some interesting things. And then what we're basically looking for here in post-boot is the system's looking to see, does hard drive and CPU become idle? Do we QS down below 20% activity, right? So 80% idle for 10 seconds.
Yeah. So CPU and disk must be 80% idle over 10 seconds that the boot process is finished. We see a lot. Mm-hmm. We go there and say, oh yeah, the desktop is there, I can move my mouse. Yeah, but the boot process is not done. According to Windows 7 on-off transition paper, which nobody read, like I didn't know there was one till I found it through a colleague. So it's like a huge white paper explaining really the on-off transitions of Windows 7, and there it confirms. Like Microsoft officially say boot is accomplished after CPU and disk is 80% idle over 10 seconds as the last phase.
Yeah. Now, one of the things that's interesting here is if you didn't have XPerf or an ETW provider to hook into to analyze all this, where would you start collecting your data? I mean, Process Monitor and things like that are still going to be collecting their data from that. So you'd be stuck with something like perfmon, right? So what's the problem with running perfmon in a boot scenario? It's not starting at system boot, it's starting in the user mode space. So we miss out on all the fun stuff, all the gory details of what's happening in driver loading and things like that. Has anyone ever collected a perfmon on a server and you have a gap, right? Collecting every 5-second interval and all of a sudden there's gaps? The system's too busy and doesn't care to write into perfmon. It's a user mode process. So with XPerf and WPA, the Windows 80K, you're much more likely to, or very likely to not have those issues because you're just subscribing to events that the kernel has built into it. It's kernel mode monitoring, if you will, rather than user mode.
Absolutely.
And I think this is you, isn't it? Yeah.
Oh, I can do
yeah,
that.
here you
Sure.
go. Yeah.
So we covered how the boot process looks like. But what is also really important when we are analyzing on-off transitions with Windows Performance Toolkit, what are the executables which we should be aware of? So, because the problem if you don't know the executables, you might see, oh, wait a minute, like winload.exe, why is it costing at that particular 30%? You don't know what is winload, what is this, what is that. So I just want to highlight some of the key processes you should be aware of. To begin with, well, we have the BIOS, of course. Then the master boot record will start with bootmgr.exe. We continue with winload.exe. As the name might give you some hints, it's responsible for the winload initialization. Then it goes over to the Windows kernel, NTOS kernel.exe, not version 2. There's no version 2.exe. If you see version 2.exe, make sure you scan your machine for virus, anti-malware. Continues to smss.exe, service management. What was it? Service management?
Subsystem something.
Subsystem something.exe. csrss.exe. And then lastly, I shouldn't walk that much over here, I think.
No.
No? Okay. So, and then winlogon.exe, which is basically the time where your user will see the log on screen. lsas.exe for the authentication. logonui.exe, again, for the logon user interface. And lastly, explorer.exe. All those executables are good. Don't think that, oh, what is that for? What is that for? Why what is it doing? Once I was on site, I was delivering a workshop around XPerf, and one of the labs was about slow boot. And basically, I went over to the student and was looking at, and he was like trying to troubleshoot the kernel because he saw the delay is there. And then I realized it's not his fault because I didn't explain him that NTOS kernel.exe is a known good thing, so it's our executable. So that's why be aware of those executables. So where does Windows Performance Toolkit or other tools, also like Event Viewer, etc., get this data from? It is coming from event tracing for Windows. ETW came with Windows, I believe, Windows 2000. So the idea was before we had thousands of different areas where we could collect logs. Each developer had his own area where he said, OK, my logs will be stored there. My logs will be stored there. Well, not really that, let's say, efficient for us as IT pros. We need to know where those logs are. We need to maybe activate those logs. And it was really a challenge for us also to find the right KB article explaining you how to activate those logs. So our product group came up then with the idea, OK, we need to improve the situation. And that's why we have event tracing for Windows in place. I personally refer to like a framework for us as IT pros where we can get most of our logs from, or most of our interesting data for diagnostics, for troubleshooting. And the really good thing about it is built into our operating system. And with regards to the overhead, so sometimes customers say, yeah, but if I run ETW, will it not cause a lot of CPU usage? Not really, because like I believe 20,000 events per second will just cause 5% CPU usage. So it's that optimized. Oh, by the way, we have 4 components within ETW. We have the ETW provider, responsible to provide specific data as requested. We have the controller, who is responsible to start the trace, tell the provider which provider I want. So the controller is like the big boss, right? He's saying, I want to have group policy provider information. I want to have it for 60 seconds, and I want to have it in an ETW data format, collected for me. The provider is getting activated, a session, an ETW session is generated around it, gets all the data collected, all the providers reporting to the session, and at the end, you have an ETW consumer, just like Windows Performance Toolkit or the Event Viewer itself, in order to consume this data. So let's talk about performance. Why is performance important? So who didn't attend the How Many Coffee Can You Drink from this gentleman, Matthew Reynolds?
Not many.
Not many. OK. So we see a lot when we are on site or when we are browsing through our social TechNet forums, customers, end user, enterprise, doesn't really matter, saying, oh, this is slow, that is slow. So it is really important for us to understand why is it slow, and more important, why is the customer, the end user, dissatisfied. And we need to find ways to make it for the end user more convenient to use their computer. Like, I think the record, how many coffee can you drink? I think 20 minutes, Matthew? 20 minutes, like that one's the record. So one enterprise customer, 20 minutes till their users can actually work with that machine. Do you think those users are happy? No. No.
You know, even more interesting, I have a customer I've been involved with that their users are told that they're all hourly employees, and they were told that when they sit down at the desk and everything and whatnot, that's when they start working. Well, they get in, they sit down, they turn on the computer, and they wait 15 minutes. And then the company turned around and said, well, we don't want to pay you for waiting. And they said, well, too bad. We're here. We're not at home. We're not in our pajamas, right? So that's a lawsuit.
Wow.
I mean, it really is. That kind of stuff matters. I mean, you look at 15 minutes a day for, hundreds, thousands of people over a year. That's money. Yeah.
Actually, I did a case study with a customer. It's one of the largest airlines in the world. It's available on TechNet, so I can talk about it. So customer agreed on that. And it was about the startup applications. So we analyzed the entire infrastructure with Windows Performance Analyzer. And what I really found was basic startup applications causing in total like 15 seconds for the computers to start. So maybe some of you would say, well, it's just 15 seconds, right? So what we did, we calculated how much money actually those 15 seconds cost the company. So what we did was we checked the average average income.
Yeah.
average salary per day for each employee, took the number, and then we calculated and say, okay, so I believe it was like 20,000 euro a day. And then we said, okay, obviously not all of those users will benefit from the 15 seconds. We still will have the guys who want to walk to the coffee and get one, right? So we just said, okay, just 10%. And basically, it's still a huge number. If you think about it, it's a per day, it was so a saving of...
I forgot the numbers.
Sorry?
I forgot the numbers, I don't know.
20,
So what,
2,000, 3,000 euro a day. If you calculate it as over a year, it's a big number. So don't assume that it's just 15 seconds will, it's just 15 seconds. It is actually a big number. And I'm sure that if it's out of the IT budget, you can use this IT budget more wisely. I don't know any company who has a budget where they say, we don't care. We have enough IT budget, particular IT budget.
One of the interesting things that I do with one of my customers is we vet out changes to the image. I support a large VDI environment. So one of the things we do is we take the image through every rev and we say, okay, the image looks like this right now through boot, through steady state, through using applications. Yeah. What does modifying the antivirus filter driver do to this picture? Or data loss prevention software, or security retention software, or monitoring software, or all the other things that security departments like to lay on an image. What is the cost in doing business for that? And so with these tools, you can actually articulate that. Okay, if you want to throw the 9th service or agent into the build, it's going to cost you X amount of performance. And that really boils down to, are the users going to complain and be unhappy, right? Or are they going to be so-so or wherever? Where are they going to be at? I think it's important or valuable that you can actually go in and articulate, well, if security wants to do X, it's going to result in Y, right? We can actually answer those equations.
Absolutely. So some of the typical issues when we talk about startup. Number one, I don't know how many times I told that already, startup and logon scripts. Fingers up who don't have a logon script. Ironic thing, like I can't do it. So we at Microsoft have logon scripts still. But we are getting away from them finally. So the problem with startup or logon scripts is basically that it takes way longer than group policies to be processed. Even a group policy preference, let's say, take it as an example, GPP, with item level targeting will be processed faster than any of your logon scripts or startup scripts. Additionally, what you have to keep in mind is a logon script, it's hard to troubleshoot. You need to look at all the code and see, okay, is that now right? And most of the time what happens also is like someone wrote the logon script, maybe he left the company and the new guy needs to read through the logon script and say, what does he mean like with that? So because usually the guy who wrote the logon script didn't take the time to write the documentation for his logon script, right? So that's why GPP offers you a way more convenient way and way faster way for your boot experience. Filter drivers are another point where we see a lot of slow boot scenarios. So basically, the driver is blocking something else. The driver is not compatible. Service grouping, what I mentioned earlier. So we have services which maybe are in a wrong order. Group policy misconfigurations. That's one of the toughest ones to troubleshoot sometimes because you have so many different environments, right? And you need to find the group policy which causes the biggest issue. So one of the examples would be synchronous mode of GPO processing, right? So basically, if you have synchronous mode for group policy processing activated, it will process one GPO, then the next one, and so on. While the default behavior will be asynchronously, basically it means like it starts nearly everything at the same time, therefore the processing time is way faster. So, but there are times where you need to do synchronous mode. So for example, folder redirection. There you have to have this GPO as in synchronous mode. Lastly, startup applications. So you might say, wait a minute, like my startup application is, let's say, audio control configurator, right? So it controls your audio. It's just 2 megabyte. And I would not agree, because the problem with that 2 megabyte startup application is most of the time it's loading in the background .NET libraries, which will, at the end, with, let's say, 5, 6 startup application, you will have 100 or 200 megabyte loaded in memory from .NET, because basically the developer will just cross-link to .NET libraries, and therefore the executable itself is 2 megabyte, with maybe loading in the background 15 megabytes on top. Talking about applications, one of the coolest tools, and which I really enjoy using from system tools, is really autoruns. Basically, you can utilize autoruns to see any applications, not only in user, but also, in machine context, which are getting started automatically. So logon scripts, Explorer, stuff coming from the Explorer.exe, LSA provider, Internet Explorer add-ins. You can see that all there. So it's really important that you verify with tools like autoruns your environment and say, okay, so let's say you're more or less sure that a particular application is causing performance issue. Go ahead and do first a trace with Windows Performance Recorder with the application, then turn it off with autoruns, and then do another trace and compare those traces. Mm-hmm. What is really, really, really important, baseline your environment. So it is really challenging if you have no baseline about your environment. So you don't know how long the boot takes. You don't know if it's expected that, let's say, Outlook or your critical applications, or SAP or whatsoever, is how long it takes. It will be harder for you to troubleshoot that performance issue than if you know already, let's say, my boot time in my environment is like, I don't know, 62 seconds. And if you then get a trace with 82 seconds, you know, okay, so there must be something wrong, right? But if you don't have a baseline, you will just start with 82 seconds and you will say, so where do I start? Like, what's my baseline? So it's, in an ideal environment, try to have a baseline, know your environment, know the performance. You can utilize for this, for example, Microsoft just released a new tool called Windows Assessment Services, which is part of the Windows ADK. If you're interested, just go on TechNet, find Windows Assessment Services, and you will find a whole how-to guide to create this Windows Assessment Services environment. It's free. Some more information about WPT. So WPT, Windows Performance Toolkit, is coming from our Windows Performance team. They are part of the Windows product group itself. And it came out originally with Windows Vista. Anyone can guess why it came out with Vista, so shortly after Vista? Some smiles. So you get the point. But we fixed a lot. And we improved. So before it was part of the Windows SDK. Now it's basically part of the Windows ADK and the setup routine I just showed you before. Now, last slide, I promise. Let's talk about the components for a second. So what are the executables I should be aware of in terms of Windows Performance Toolkit? So before, in version 4, so before it was part of the ADK, before it was part of the ADK, we had 3 main components. We had xperf view.exe, which is the ETW consumer, xperf.exe, ETW controller, as well as xbootmgr.exe, which was also an ETW controller. The pain point there was xperf.exe as well as xbootmgr.exe. You had to know the command lines. You need to know the syntax because, well, it was command line based. Now we simplified this, and we have the WPA as an analyzer, so the ETW consumer, and we have wrui.exe as the ETW controller. So I make it now simple. What are the main components of version 4? Come on, guys. No, you have to read that. Come on. There was a guy, just pointing it out like this. What? You don't want it? Like, it's laughing?
Careful, you might hurt somebody.
Yeah. All right. Demo time. So I'm really not sure if the internet's slow or my mind is suddenly faster. So let's have a look. Let's move to my machine. Let's log on.
Why did that take so long? No, I'm kidding.
Why it takes so long? It was 2 seconds. Come on.
We should trace it.
Yeah, I actually, you know, I trace my machine like every 2 weeks.
Yeah?
Just to see, and then I annoy our MSIT guys if I find something.
Yeah? Okay.
Oh, I saw in this area there was a 3-second delay. Fix it for me. I think they have like a, you know, if they open my record on MSIT, it's probably like a pop-up, a flash, most annoying customer of the world.
Maybe.
Matthew, what do you think? Is there a pop-up? Yeah. So Matthew works with MSIT, so it's hard-coded. All right, so I got my server up and running. And here I have my client. So let me log on and use the Windows Performance Recorder to trace my boot experience. What I also use from sysinternals is for that autologon.exe, because the thing is, imagine if I would trace it like that, there will be still the time in my trace where the user enters a password, and I don't want to have that in my trace, because it's not really relevant for me how long it takes for the end user to type in his password, right? So I use autologon.exe to make an autologon on that particular session, so let me grab that one. Sysinternals, autologon. Let's start, yes. Type in my super secret password. Enable it. And now I would say, everyone can see it, right?
Mm-hmm.
Cool. As a performance scenario, I want to have a boot trace. So I'm choosing boot. I stick to verbose. I want to dump it to a file since it's an on-off transition. And now I can also choose, okay, how many times do I want to do it? So since it's just an example, I would go with 1. By the way, it might be a good idea for you also to do it 6 times when it's a machine you just deployed. Reason for that is, for ready boot, it takes up to 6 reboots till ready boot prefetching is all accomplished for your machine. So sometimes maybe you would notice that when your machine, you just installed your machine, it's a bit slow, and then it gets faster, faster, and faster. It's because ready boot is still prefetching, and it takes 6 reboots. All right, so now I don't require really additional resource analysis, so I'm going to start this trace. Hello world. Save. And now it's asking me, well, it's informing me that there was a reboot required. Hit OK. OK, take care, guys. No, just kidding. So, I should do that one. So the problem with that demo is it's a 20-minute boot, and we have 15 minutes left. So again, I prepared. All right, so basically, it is stuck now here at this phase, so welcome. It's like for 10, 15 minutes. So I have the trace already on my host machine. So let me know.
Yep.
No, it's not full size. If you look at it here.
Yeah, just use the monitor up front.
Oh, yeah. Good idea. All right. OK. So let me just, 1 second. OK, cool. So now I have the trace open of my slow boot. What I would do then is, on the system activity, I have a graph called boot faces. I will move it over here. Oh, do I have zoom it on? No. Let me start zoom it so you can see it better. Okay. So here I have moved over the boot faces graph. And what I'm really interested in now is basically to find out really, okay, which area of the boot is responsible for this experience. Well, you might see it already. So here I have WinLogOn, right, which has a huge delay. If I hover over it with my mouse, I can see the total duration, which is 10 minutes. So it takes 10 minutes for WinLogOn to get ready. So let's see what we are doing there, right? For this, I have an additional graph, which is basically, well, WinLogOn. Windows logon, the graph called Windows logon, showing me exactly what is happening in the WinLogOn phase. And here I found again quickly my gap, right? Just double click on it, and let's see what it says. So here you can see now the subscriber is GP client, group policy client, taking in total 10 minutes. But that's not enough, right? So just know, okay, so it's group policy taking 10 minutes. It's not enough, right? So now let's drill into it. And what I want to know is basically, I want to move the so-called generic events. Generic events are events where we don't have a graph for it, right? So you will have the providers listed there, and you can still utilize them, but there's no extra user interface for it, but you don't have to. So let me show you now how I would analyze it. So basically, I open here, over here, the details for this graph. Let me close this one as well. Move that over here. And now what I want to know is, what is Microsoft Windows Group Policy Reporting? So let me open that. And actually, just moving all of this column over here. And we don't need process. Great. Okay. Oh.
I think you get rid of provider.
Oh, I killed the provider?
Yeah.
Okay, sorry. Provider, process. Oh.
There you go. Looks like it's hosed up. Yeah, yank it over there. Just kill it.
Provider name.
Yeah.
Okay, now we got it. Let's drop that one. Okay, so group policy. So on the right side, we have the time. So how long did the processing of each phase took, right? And we have the opcodes over here. So basically win start, something gets started, and we have win stops. So what I'm really interested in to see, okay, when do I see within the time column a bigger gap? So for that, I'm moving down. Everything is good. 10, 11, 18. No gap. Let's see what is the last thing. What is getting reported by Microsoft Windows Group Policy, which is basically WinStart svc host.exe, which is fine. What is it doing? It's a script type, logon script. And just before that, there's a startup script. Let me right-click, and let's see. No, actually, be here. All right. So we see that the last thing which is getting processed is a logon script. Let's drill into that part. For that, I will now go ahead and move the process graph over here. Mm-hmm. Close this one. Click again on the detail graph, because I want to know the relationship between, like, who did actually executed this command, or who did actually executed this logon script. So now I'm again watching basically out for bigger gaps within the start area. 10, there we have bigger gaps. Let's see where GP script is. So we got GP script over here, which took 136 seconds to process gpscript.exe-logon. And if we go a bit down, we can see something called agent.exe here. So the process, so the logon script is executing, is getting something from the domain controller DC1, share agent.exe. What's really good is about Windows Performance Analyzer also, you can say, okay, I want to know the parent process ID as well as process ID. So you can find who's starting what. Let's go over here. So now if I go to gpscript.exe, so we have here gpscript.exe with the process ID 2296. And we see over here the same process ID, so 2296, which is starting PowerShell.exe. And if you're diving deeper, you will see actually that group policy gpscript.exe is starting PowerShell.exe. PowerShell.exe is starting then the logon script, which is basically causing the delay. And what is really interesting now is if you look at the computation graph. Let me move it over here. You will find a correlation. Basically, we see straight away, I think, that something is growing really fast, and it's taking 100% CPU time. And now we can see it is the agent.exe, which is causing high CPU. So GP script starting PowerShell.exe, which is responsible to start a logon script. And if we watch carefully the command line, it is starting agent.exe. And we have the proof over the computation graph that this one is causing the high CPU. So what happened basically was, let me open my server. So I built the slab based on a customer scenario. And let me open group policy for you, group policy management. So let me just see if it's that one. No. Yeah. So the customer had a logon script, which is, well, it's not okay, but it's acceptable, let's say. But the problem was that he had additionally decided to run this synchronously. So there was a dependency, so everyone was waiting that agent.exe is done with his job. But since it's never done, agent.exe is actually a CPU stress.exe, so it's responsible to stress the CPU. That's why it runs sometime into a timeout. So according to our transition white paper, the WinLogon notification timeout happens after 10 minutes. So after 10 minutes, we decide, okay, let it go. And that's what happened, because the logon script was never done. It was never accomplished. It ran into a timeout after 10 minutes, and then the boot continued. So that's the reason why this machine had a slow boot experience. So what we did basically was we removed, first of all, run synchronously, so that the customer said, I want to have my agent installed. Fair enough, right? But we removed synchronously because there was no need for running it synchronously. And with that, the machine was up within 2 minutes. All right.
Questions? 6 minutes. You want to do questions?
Yeah. So this is one of my let's take a nap demos. Now we are open for questions. If there are any questions, we still have 5 minutes. Yes? Mm-hmm. Okay. Yeah. Okay, so as far as I've understood, the question is, can I run Windows Performance Recorder for, let's say, multiple days, or what is the best practice from Microsoft? What's Microsoft's standpoint? How long you should run Windows Performance Recorder?
I would say probably 10 minutes is a max, but the trick is that do you need to know what's happening over a week, or do you need to know what happens during the event for the last 10 minutes of the box? Because you can easily do circular logging. What's what?
What is
Circular logging? So it'd basically be a black box where we would continually log whatever providers you would choose in your trace, and we would log them to the file, and then once we fill the file to a certain size, we start overwriting the first, right? So, I mean, you can keep a log. We did, in the VDI one I did yesterday, session I did yesterday, we talked about having a black box for every VDI guest. So basically, if you're having guest issues, the user can invoke a button that stops the ETW trace provider, and you've got the last 5 minutes of what the user was up to.
So does the tool show you how to do circumstance mode?
Circular logging? No. It's a command line option, but it's very well documented on TechNet, and I actually list the black box recorder in the other session on VDI I did yesterday. It's in the PowerPoint.
Yeah.
Another question?
Yes? So the question is what you do if the events are unpredictable.
Yeah. I mean, that's why I would use a black box recorder, so it's always
Yes.
recording. The thing, I used to be an escalation engineer for Exchange, and the most frustrating thing is you have an event where something goes down and the business is impacted, blah, 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 millions of dollars lost, et cetera, and it's okay, well, configure your machine properly for a dump, and next time it happens, collect the dump file and call me back. What do? We did nothing. We did nothing to fix the problem, right? So if we have things set up to constantly be there, prepared to collect data or already collecting data, you can do the same thing with perfmon for long-running things, right?
I think one of the key things is that Windows Performance Toolkit, it's not a proactive solution. It is a reactive-based solution mainly.
Yeah.
Right? So
That's
it
true.
happens after the issue came. So you need to be able to reproduce this issue. If you want to have a proactive system, then you would go with SCCM, SCOM, and Z-Sheen. German. Z-Line, sorry. Other questions? No? Yeah. Cool. Then,
Thanks.
thank you, everybody. I hope you
Have fun.
enjoyed it.